Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at a force equation that we're going to find from a oscillating pendulum. So without any further ado, let's get into the problem. Problem 3 reads, a 5 kilogram mega rubber duck is suspended by an ideal string to hypnotize the unsuspecting. Its position function is x of t is equal to 0.8 cosine 2t. Part A is asking us, what is the magnitude of maximum net force that acts on the duck? Alright, so from our forces unit, we know that force is simply mass times acceleration. And we're given the mass, we don't know the acceleration, but what we do know is the position function. And we know that the acceleration is just the second derivative of position. So let's take two derivatives of this function in order to find our acceleration. If x of t is equal to 0.8 cosine 2t, v of t is going to be equal to negative 0.8 sine 2t times the derivative of the inside, which is going to give you 2. And finally, to find our acceleration, that's just going to be the derivative of this right here, which will be negative 0.8 cosine 2t times another 2. 2 times 2 will be 4. We can move this 4 up front. 0.8 times 4 is going to be 3.2, so we'll have negative 3.2 cosine 2t. And when we want to find the maximum value of this function, we know that cosine ranges from negative 1 to 1. And obviously this acceleration is going to be greatest when the cosine is negative 1. So we'll set this to negative 1. That'll give us negative 3.2 times negative 1. A max is going to be 3.2. Now let's plug that into our equation here. We'll get F is equal to our mass, which is 5 times 3.2 meters per second squared. And 5 times 3.2 will give you 16. And the unit for force is newtons. Alright, so now that we found that, let's just move on to part B, which is frequency. Now let's write out the equation for frequency that we know. We know that since omega is 2 pi frequency, our frequency is simply omega over 2 pi. And looking at this equation right here, we know that our standard equation for displacement when it comes to pendulums is a cosine, or it can be cosine or sine, but in this case, since we have a cosine, we're going to go with cosine. A cosine omega t. And so from here we can see that our omega is just simply 2. And when we plug that in here, frequency is omega over 2 pi. Plug in the omega, that'll give us 2 over 2 pi. And the 2's cancel, so your frequency is going to be 1 over pi. And that one is going to be in terms of hertz. That's all I have for you guys today. Make sure to tune in later for more physics tutorials.